Hello. Okay, so I'm going to record this video for you guys. If you guys have trouble finding median, mode, mean, and standard deviation. So this is something, if any of you are taking probability and statistics next year, which is a big chunk of you actually, I would suggest trying to do this because this will only prepare you for next year. And I believe that a lot of you have no idea what standard deviation is. So hopefully this will help. Okay, but anyway, so let's take the coronavirus data in Hawaii from April 24th. Okay, so this is actually real data. I took this over 7 days. So there were 6 cases on April 18th, 4 cases on April 19th, 2 cases on April 20th, 6 cases on April 21st, 6 cases on April 22nd, 4 cases on April 23rd, and 5 cases on April 24th. Okay, so there's 6 cases one day, 4 cases on another day, 2 cases on another day, 6 cases on another day, 6 cases on another day, 4 cases on another day, and 5 cases on another day. Okay, first what we want to do is we want to reorganize this data from least to greatest. So I'm hoping you guys can do that. That's really easy. 2, 4, 4, 5, 6, 6, 6. Okay, that's not too hard. I'm hoping you guys can do that. Okay, what is the median of coronavirus cases in the past 7 days? All right, so if you guys forgot how to find median is basically the middle number. The middle number of a data set. Okay, so if I write that all out, write all of this out again, there are 7 numbers here. The middle number is this 5. Do you see that? Because if I go 3 numbers from the left and 3 numbers from the right, the median number of cases is going to be 5 cases. I'm hoping you guys remember that from elementary school. If you guys don't remember that from elementary school, good luck in prop stats. Okay. Next part, what is the mode of the coronavirus cases in the past 7 days? So if you want to find the mode is found by looking at how many times the data is repeated the most. So if you look at this, if you look at this, there's 1 day where there's 2 cases, 2 days where there's 4 cases, 1 day where there's 5 cases, and 3 days when there were 6 cases. So 3 times. So this is the data set that occurred the most. So that would be the mode. The mode is 6 cases. So just look at the number that occurs the most. Maybe I should write that. Number that occurs. I can't spell. Number that occurs the most. Okay. Next part. What is the mean of the coronavirus cases in the past 7 days? Okay. Mean is denoted by this thing called X bar. X bar basically says you take the average. Mean, if you guys forgot what mean was, mean stands for average. So you take the average of this set. We have 7 sets of data that we're looking at. We divide by 7. So 2 plus 4 plus 4 plus 5 plus 6 plus 6 plus 6, and divide this by 7. Okay, so very easy. 2 plus 4 plus 4 plus 5 plus 6 plus 6 plus 6. So this is 33. And you take 33 divided by 7. So 33 divided by 7 is approximately 4.714. So that's the mean. The mean will be about 4.714 cases. So that's the average based off this data set. That means on average we're getting about 4.7 cases a day. Okay. Now, standard deviation. Okay. So what is the standard deviation of the coronavirus cases in so many days? Okay. So this formula is used for standard deviation. So S stands for standard deviation. This on top here is a square root. This might seem kind of not seem very familiar to you guys. This sigma means the sum of. So you're taking the sum of all your data sets. So the 2, the 4, the 4, the 5, the 6, the 6, the 6. You take the sum of all the data sets, subtract for each data set, you need to subtract it from the mean, take that quantity and square it. And once you take that quantity and square it for each data set, you have to add all of them up. That's what the sum, sigma notation, that means the sum of. You add it all up, and then you divide by the number of samples you have, n minus 1. Okay, so what I did here was I created a table. This is the reason why I only considered 7 cases. So because this part gets kind of tedious. So if you see here, I listed all my data sets. We had one day with 2 cases, 2 days we had 4 cases, 1 day we had 5 cases, 3 days we had 6 cases. Okay, this is our average. This is our mean. So x minus the average is taken by 2 minus 4.714. And then you can create this all over here. Now, if you guys take probability statistics, you might learn on Excel. Like, this might be a lot easier to do on Excel, honestly. But what I'm showing you is just the process on what you would do. And I believe if some of you are proficient in Excel, doing this calculation will be really easy to do. Okay, now this part. So you, like I said earlier, in order to find just this quantity here, you have to take what's in this, put it in parentheses, and square it. So your output here, for each output that you see here, you have to square it. So once you square each of these quantities, then you have to add up all the numbers in this column. If you add up all the numbers in this column, that's how you get this 13.4294. Okay, now once you go through that, I know this will take a while to do, you can go ahead and calculate the standard deviation. Okay, so the standard deviation S is equal to the square root of the sum of x minus the data set minus the average squared divided by the number of samples minus 1. Okay, so if you look here, the sum of x minus the average squared, this is this 13.4294. That is what goes here. Okay, 13.4294. And we're dividing this by the number of samples we have. The number of samples we have is going to be 7 minus 1. Okay? So what I see here is we can simplify this. So 7 minus 1 is 6. So square root of 13.4294 divided by 6. Okay? Now you can use a calculator to solve that, right? So if I were to do that right now, so square root of 13.4294, I'm going to divide that by 6. So this is approximately 1.496. Okay, so this would represent our standard deviation. It's about 1.496 cases. All right. So now what I want to do is I want to explain what how the standard deviation compares to the mean. Okay, so on the next page here, so it said let's analyze the data from previously. So we said the average number of cases, coronavirus cases in the last 7 days. So we know this is our mean. This is our average, x bar. This is our standard deviation. Standard deviation, if you look up a definition for standard deviation, it basically tells you the range of how far your values are from the actual average or the mean. Okay, so let's draw a picture. So I'll draw a picture for you guys. So remember that final that everyone almost bombed, and then I had to go ahead and curve it for you guys. So one way to a picture of this is every time you guys take a test, I give you guys an average and I give you guys a set of data and stuff. So the mean, if it's a well-designed test, usually the mean will be right in the middle. This represents x bar. So in other words, let's say this is 4.714. This is the amount of cases that are in Hawaii. Okay. Standard deviation. Standard deviation basically says that if I take 4.714 minus 1.496, that's how I get 3.218. So that means the range of values of the average is going to be somewhere, on average, is going to be somewhere between 3.218, and then if we add this 4.714 plus 1.496, and that's 6.21. So 6.21 is what would go there. So if you guys see, so this is what S represents. So this would be minus S, and this would be plus S. So standard deviation basically tells you how far you are away from the actual average. Okay, so hopefully a little picture kind of helps you out with that. Okay, now, so let's take that same data and add a new point. So this is actually real data. The third point, I believe, this is the number of cases on April 25th. So this represents April 25th. So this is, in real time. This is really happening right now. Okay. So what would happen if there were, 3 new cases on the 8th day? Okay. So we want to reorganize again this data from least to greatest. So if we reorganize this data from least to greatest, this is 2 goes here, 3 goes here, 4, 4, 5, and then 3 6s. Okay. What is the median of the coronavirus cases over 8 days? Median. So again, basic this is what you hopefully remembered in elementary school. So you have 8 sets of data, you're looking for the middle number. If we look at it, we don't have a really defined middle number like the first example. So the middle would be literally right here. So in order to find the median, it would be somewhere between 4 and 5. So halfway between 4 and 5 is 4.5. So this means the median is going to be about 4.5 cases. So median is going to be about 4.5 cases per day. Okay. What is the mode? So look at the mode. We're looking at the data set that occurs the most. So obviously, if you just look at it, we have one day where we had 2 cases. We had 1 day where it's 3 cases, 2 days, 4 cases, 1 day with 5 cases, 3 days with 6. This one is still dominant. So we have 6 cases. Okay. Yeah. What is the mean of the coronavirus cases? over 8 days. So if you guys know how to find the mean is found by taking all your data set. That's the average, right? 2 plus 3 plus 4 plus 4 plus 5 plus 6 plus 6 plus 6. Divide this by 8 days. Okay, so if we were to go ahead and add that data in, so we have 36 divided by 8, and 36 divided by 8 is going to be 4.5. So it just so happens this mean is the same as the number of is the same as the median. That was just a coincidence. Doesn't always happen like that. But the mean of coronavirus cases that would happen over 8 days is about 4.5 cases. Okay. Next part. Okay. So, what is the standard deviation of the coronavirus cases over 8 days? Okay. So, again, what we did, I took this data here, 2, 3, 4, 4, 5, 6, 6, 6. That is our data that we're analyzing right here. Okay. The mean, the average of the coronavirus case over 8 days is going to be 4.5. So we have 4.5 here. We have to find x minus x bar for this equation. We're doing the same thing that we did for standard deviation. X minus x bar. So you take 2 minus 4.5, 3 minus 4.5, etc., etc., etc. You're going to get a whole bunch of values that look like this. Okay. Now the next part we need is we need to put this in parentheses and square it. Okay. So we found all this data here. So x minus x bar, or x minus the average, and then we just square these quantities, and we get all of these nice values here. Okay. Now the next part in this here is we take the sum of this data. We take the sum of all this data that we have here. So 6.25 plus 2.25 plus 0.25, etc., etc., etc. Add these numbers up. Add it up, add it up, add it up. You get 16. Okay. So what we need to do is we need to actually find the standard deviation. Okay, so the standard deviation for this, okay, so we're using that formula again. Standard deviation equals the square root of x minus x bar squared divided by n minus 1. Okay, so what we have here is we added up all of this, so this gets substituted here for this expression. So we're finding the square root of 16 over the number of samples we have. We have 1, 2, 3, 4, 5, 6, 7, 8 samples. So 8 minus 1. Okay, so this is the square root of 16 divided by 8 minus 1, which is 7. Okay, so now what we need to do is we need to find the standard deviation. So this is the square root of 16 divided by 7. And I have here, if I just round, this is about 1.512, about 1.512 cases. So this represents the spread of how far it is, plus or minus, from the average. Okay. Now, let's go ahead and compare some of this data. Let's go ahead and compare some of this data with the first data that we had. So, how does this compare to the data in the past 7 days? Okay, so what we had earlier, right? We had something that looks like this, right? So earlier we had 4.714 cases, and then it goes to about 3.218, and it goes to about 6.21. So this is what we started off with originally, something that looks like this. Now, if we add a new data point here, if we added a new data point, we knew that we had 3 cases. By having 3 cases, the new data set says that our average dropped to 4.5, and then our new standard deviation, if we had to go ahead and use that, so we're finding 4.5 plus or minus 1.512, right? So this represents the average. This number represents the standard deviation. Okay, so what we would do is we need to find this. So 4.5 plus 1.512, and this is about 6.012. So that means this data point is probably somewhere around here, 6.012. And we have 4.5 minus 1.512. And I think this is about 2.988. So this is going to be somewhere around here, 2.988. Those dots represent the new data. Okay, so if you look at this, the score that we had earlier, I mean, not score, sorry, I'm thinking test score. The number of cases that we had earlier. So we have 3 new cases, right? So I have here, we have 3 new cases. If you look at what we started off with originally, we said that our data had, our average was between 3.218 and 6.21, right? Because the 3 new cases fell out of this range here, this means, so if I'm going to answer this question first, standard deviation. Because it fell out of this range of values, this means that the standard deviation should increase. So the standard deviation should increase. And the reason why for this is because we're getting farther and farther from the actual mean or average that we had earlier. I can even show you like what we calculated here. So we said the standard deviation is 1.512 cases for, this is our new data set, right? Our old data set here said that we have 1.496 cases, right? So our standard deviation increased. So that's one way to think about it. Okay. If you look at the mean here, these are the values for the average, right? So does the mean increase or decrease? If you look at this, we started off with 4.714 cases per day. Because we dropped, we have 3 new cases on the 8th day, right? So this number, if you want to consider that this is the old data, right? The old data is greater than the new data, right? This is the new data. Sorry, running out of room here. So does the mean increase or decrease? This is our new average, 4.5. So the mean had to decrease. Okay. So yeah, sorry, that was kind of a lot. But hopefully that makes sense for some of you that were having trouble with that particular problem. I think it was quarantine assignment number 3, I think, where you guys, yeah, some of you just had no idea what standard deviation is, which is totally fine. So if you guys are taking prob stats next year, I would hope that you would try this particular assignment that I'm assigning you guys. It is a bit it's not too hard actually, it's just very tedious, but it will definitely help you guys if you do it. Okay, anyway, let me know if you have any questions, and I'll see you later.